if you didn't grab a ruler, you may want one for the next example. You don't need one immediately.
Hey, Q, give me that back. Mrs. Drusella, can I make this Friday even better? No homework? No homework. It would be.
They're in that box.
Oh.
If you're nice.
Whoa.
See. Y'all could not say. With that, I know.
Don't say it's like I know someone. Stop it. You know.
Got him.
All right. What? I am losing my patience.
Shh.
Oh yeah. No, Amo, whatever.
I'm sorry.
That's exactly what you're like.
Okay, so we are graphing derivatives. I had led us into this, I was talking about yesterday, I believe, where you're given the graph of a function. You don't know what the equation of the function is. You are given the graph. You are not meant to try and write the equation of the function and then find what the derivative is and graph it. You're just using the relationships between a function and its derivative to make a graph. So I had already done this for the first graph. We're using the ideas of slopes of tangent lines to graph the derivative, since the derivative represents the slope of the tangent line to a curve at any point. So I drew in, or tried to draw in, the points at approximately which I had drawn the tangent lines to start. So you would be drawing your own tangent lines for the second one. And that's where you may want to use the rulers. But this is not something you will be doing every single time where you're drawing in tangent lines like this. It's just as an introduction to get you understanding the idea of how to graph these, or how to think about the graphs. So what I did is at these 5 points, I drew in approximately where the tangent line would be, and I want to then find, using algebra, the idea of this, or rise over run, to find the slope of the lines that I drew, so that I know the slope of those tangent lines, and I know the slope of those tangent lines is going to be the value of the derivative at those points. So this first point I drew is approximately at, it's not quite at negative 1.5, maybe negative 1.3. Yeah. So to find the derivative f prime at the x value negative 1.3 approximately, so that would be the slope of the tangent line to the curve at that point. And that is this line that I had already included for you. So you're trying to approximate what the rise over the run of that line would be. So what did you say it was? About -2. So let's say if I go down to maybe this here, I'm going down to and over, a little over, a little bit more than 1. So I'm going down to, so my rise over run would be -2 over we could approximate it as 1.1, 1.2, roughly. Realize this is an estimation, so I will say, if you, like me, like math because things are very exact, this is not exact. This is an estimation. It's okay, you'll all live. But this is more of an estimation. You're gaining the idea. That's what's important. When we're coming up with these values, this is just to help you get the idea. The idea is the most important that for you to understand here. So this would be approximately so I have -1.6 repeating, so -1 2/3. Okay, and I'm going to do that for the other 4 points as well. So the next tangent line I drew in was at the x value, a -1. So I can approximate f prime of -1 by finding the slope of that tangent line. So this tangent line, if I say go from the point of tangent C where it crosses the y-axis, this is pretty close to just down 1 over 1. So this is pretty close to -1 over 1 or just -1. Again, it's approximate. Ultimately, in the end, we're just doing this for the first 2 graphs to get the idea. Ultimately, you won't be drawing in tangent lines every single time. This is to get you to see the relationships between the graphs so that you would just see a graph and you would start sketching the derivative. So then the next one I have was at the x value 0. Yep, and that was a horizontal tangent, so that slope is 0. That would be the derivative of the function at 0. And then the next one was at +1. And now what you're going to see with this curve in particular, yep, so it's going to be the exact opposite of the slope at -1. So now this would be a positive slope of up 1 over 1. So it's +1. And then the next one, it was meant to be symmetric. So if we said the first one we found was at about -1.3, this would be at about +1.3 for the last one. And so that should also be the exact opposite then for this curve, and we could see that if we looked at it, it'd be the exact opposite of what we had for the very first one. So it would be up 2 and then over 1.2 approximately. So a +1 2/3. Now again, this is all approximate. Carissa? For this one?
Yeah.
So for f prime of 1, you could go, where am I on the orange one? If I was going from this point to this point, I would be going down 1 but left 1, which would also be negative. No, not unless you're, because I'm going off of this tangent line. So if it went through the origin, you could, but it was just from one point to another on that same line. All right, so are there any other questions on where I was getting these values? And again, they're approximations. So if you had just looked at this on your own, you might be getting slightly different answers. They shouldn't vary greatly, but slightly different. Okay, so here's the idea. To graph f prime of x, then these are all points on the graph of f prime. So these would give me 5 points. 1 point is negative 1.3, negative 1 2/3, approximately. 1 point is negative 1, negative 1. 0, 0, 1, 1, and then 1.3 and 1 2/3. Again, approximately. So you can plot those 5 points and then draw a line or a smooth curve through them to graph the derivative. So if I were to do that, you should see these points very closely, and really they should for this type of curve. We don't, well, some of you might know that depending on, I know physics does some of these relationships as well, but because of this being a parabola, this derivative would be a line. It would be linear. We can see that it approximately is. I should have used a ruler to draw it in. Our points do approximately make a line. And that would be the graph of f prime of x. Okay, so while you will not do this for every single one because it is, sorry for a tedious process, you do not always have to pick certain points, draw the tangent line, find the slope of the tangent line to plot a point for f prime and then draw your graph through. This is purely to get you the idea of what f prime is representing. So all of the points on the graph of f prime do represent the slopes of f at those points. But it's to also look at the relationships. So looking back or thinking back to the relationships we talked about yesterday, some things to notice here is that where f had a horizontal tangent, that is where f prime was equal to 0. So anywhere that f is going to have a horizontal tangent line, the derivative will cross the x-axis. We talked about that yesterday. And then also, we talked about the relationship between f, or the original function, increasing and decreasing, and what that meant for f prime. So notice on the interval from negative infinity up to 0, f is decreasing, and your derivative then, all of these values are negative. So if f is decreasing, that means the derivative will be negative. All those y values are below the x-axis. If f is increasing, as it is from 0 to positive infinity, then f prime, all of those values are positive. So if you even want to write that in, when f decreases, f prime of x is less than 0 or is negative. When f increases, f prime of x is positive or greater than 0. Okay, these ideas that we're introducing here, or rather, I know I introduced them for the first time yesterday, these ideas are huge and will be talked about the rest of this year. So anytime you know a function is decreasing or increasing and you're asked what can you say about the derivative, if I say if f is decreasing, what's happening with f prime, you should know it's negative, or it's below the x-axis on a graph. This. If you're dealing with polynomials, yes. Yep. And you may have started to see that with the polynomials we've been working with algebraically too. With polynomials, it is true that the derivative is always 1 degree less than the original function. All right, so for the second one, I know it says graph 4, don't really pay attention to that. But what I did include for you is I gave you some values I'd like you to find the derivative of or approximate the derivative of at those values. So you can use the rulers to draw in a tangent line if you need to approximate what the slope would be, and then use those points to draw what the curve of f prime would look like. So work through this, and then the next ones after this, if you want to look ahead, you can. We're going to go through them. We are not drawing tangent lines for those. We're just going to use the ideas we've been talking about to graph or sketch the graph of those derivatives. If you feel confident in trying to graph it without drawing tangent lines, you can. We'll talk more about that with the next example. So too.
Yeah, I'm not trying to. Oh, I got the same one. Oh,
It's not like
you brothers. Hard. Oh yeah. Not exactly. Take less acceleration. Oh. Oh, I did. Look at that. Here, you got that.
Oh, graph. Oh, it's here. No, no, because down. Graph. No. We're still on that problem though? Yeah. Oh no. What he does.
All right. I would like to, I know some of you are finishing up with your points, but I think from what I'm seeing that you'll at least get the right shape. So it should be in the shape of a parabola approximately. Okay, ultimately, this curve you're given would be a third degree, or appears to be a third degree, so a parabola would make sense. And then I know I was saying to some of you, don't focus too much on these values because you will not be doing this every time to graph these. And this is not an exact graph. This is an approximation. When I grade these, I'm looking to see, do you understand what the shape of f prime should be? The shape of the graph. That's what I'm looking for. So I would like you, well, actually, quickly to talk more about this one. Again, notice, I'm just going to make a couple of marks on here. I'm off a little bit. Okay. A couple things to notice, the ideas we talked about in the last one. From negative infinity, this is like one of the examples we looked at yesterday too. From negative infinity up to that local max, the graph of f is increasing, and notice that's where f prime is positive above the x-axis. Then from the local max to the min, f is decreasing. All of those y values in f prime are below the x-axis, they're negative. And then f starts to increase again, and the graph is now above the x-axis positive again for f prime. So when f is increasing, f prime is positive. When f is decreasing, f prime is negative. So we're going to use those ideas for these next ones.
Wait, stop that.
We have 7 minutes. We need to get through these so you know what's going on. For the, on that next page, the top one, I'm not going to have you draw tangent lines in for this. I know some of you working ahead may have drawn tangent lines, and that's okay. But I ultimately want you to be able to sketch the graph without having to do that. That's just to get you the idea of how these graphs are related. So if this is the graph of f, At any point, does F have a horizontal tangent line? Horizontal tangent line. So this curve is approaching a horizontal tangent line, but won't ever have one. So if F never has a horizontal tangent line, this means F prime of X will never equal 0. That doesn't make sense English-wise, so ignore that. But you get the idea. F prime of X is never 0. That's what it's meant to say. It's Friday. Okay, so F prime of X is never going to cross the x-axis. F of X is always increasing. This curve is increasing on its entire domain. What does that tell us about F prime if F is always increasing? F prime is always positive. Okay, so F prime of X will always be positive. The entire graph for F prime should be above the x-axis. Okay, now the exact values of F prime is not our concern. Again, I'm looking to see do you have the shape, and then the placement on the graph is approximately correct. So how to also look at this to get the shape. If you were to draw tangent lines in, these tangent lines at the beginning are going to start out very, very steep. And then as you draw lines along the curve, they slowly become more and more horizontal. So because the slopes start steep, and approach 0, that's explaining what happens on the graph of F prime. This means the y values on F prime are going to start out very, very large because those are steep slopes. But then F prime is going to approach 0. And again, it's always above the x-axis and never actually touches the x-axis. So F prime is going to start out with high y values and approach 0, but never actually touch it. And there's your graph of F prime. Okay, questions on that? Is that what? Oh, like is it exponential? It could be. All right, we'll look at the next one here. We'll look at this next one and then end here. So for this graph, guys, I need your attention. Does this graph have any horizontal tangent lines? No. So again, F prime of X, I'll write this one correctly, is never 0. I kind of like never be 0 though. And then in terms of increasing, decreasing, what's going on with F here? It's decreasing everywhere on its domain. So because the y-axis is a vertical asymptote for F, it will also be an asymptote for F prime. But both parts of this curve are decreasing. And what does that mean about F prime? It's always negative. Okay, so to draw this in, the entire graph for F prime should be below the x-axis. It's never actually crossing the x-axis. For this first part, these slopes are starting out close to 0 and getting steeper, meaning F prime starts close to 0 and gets more and more negative. So that part of F prime will look almost the exact same. This next piece, though, these slopes start steep and now approach 0, and they're steep negative. So those y values start very low and negative, and approach 0. And that would be the graph of f prime. Okay, so we're going to look at the next couple of graphs at the beginning on Monday, and then you'll have some to practice in class before we move ahead. There's no homework.